All right. Hi. We'll be talking about 1845, our digital design capstone. The game that we will be making is a Donkey Kong arcade game. It was developed by Nintendo in 1981. It's one of the early examples of a platform game where we control a main character who jumps between suspended platforms. The gameplay is maneuvering the main character Mario across a series of platforms by climbing ladders and jumping over obstacles, which include like barrels and fireballs. The aim is to get to the top of the screen and rescue the damsel in distress who's being held captive by Donkey Kong, who is the antagonist. There are four unique levels in the gameplay. The gameplay premise remains the same with the obstacle. You know, you got to jump levels and cross obstacles, but the gameplay gets harder. You know, levels get harder to obstacles become like a lot more difficult. At the end of the fourth level, if Mario is able to knock down the tower with Donkey Kong in it, the game ends and Mario saves the damsel in distress. Um, okay, so the input controls for the game are a four-way joystick to move Mario, and a jump button, a start button, and a coin insert button, which we'll be programming to allow us to play the game. The outputs for the game is just a simple video output display on screen and audio output that includes like background music, tunes, phrases, catchphrases, etc.
Everyone stay in frame. The tech specs for this project will be using the main CPU as a Z80 Zilog processor at 3.072 megahertz. It's a very popular 8-bit microprocessor used in thousands of consumer electronics in the late 70s to mid 80s. Uses three 16-bit registers, an 8-bit accumulator, a stack pointer, a program counter, two 16-bit index-based registers, and a status flag register. The ISA uses 8-bit opcode encoding with 252 and /256 used. It's compatible with peripherals like counter time circuit, serial and parallel input-output, direct memory access, and dual and asynchronous receiver transmitter (DART). The sound chip for this was the Intel MCS 48 i8035 at 400 kilohertz, and it was one of the first microcontrollers produced by Intel in 1976. The i8035 has 64 kilobits of RAM and no ROM, and it has a simple function of generating background music and foreground music for the game. The sound is then produced by a DAC at 400 kilohertz, which translates to audio samples from the i8035 into sound waves. The monitor for the game was a standard CRT monitor with a resolution of 224 by 256, and the game used raster graphics to display the images on screen, and bitmaps that store information that corresponded bit by bit to each pixel on the screen.
As far as research we've performed, we've looked up the game manuals and schematics for the original arcade game. They're very analog, so we'll not use them too much. But they show how the different pieces of hardware are interfaced together and how they're connected. We also found source code for the game, and we also have the MAME source code, Multiple Arcade Machine Emulator. We have an assembly version of the game source code that we have not tested. We will be testing that as part of our project. For the main CPU, we have a Verilog implementation of the Z80 processor, which is, again, the primary processor that the game runs on. As far as our basic planning, we will be following the path of the 1942 project, or we will be trying to, as they are perhaps the most successful example of an arcade game. As far as what we're using the Vertex 5 LX board, which has a Vertex 5 LX 110T chip on it. Ideally, we want to use the arcade console designed by the Multi-Williams team in fall 2009 to interface with our game.
All right. That's pretty much it. Anything else?
Nope.
Okay.